All right, I am going to get started. Today we are talking about complex numbers in polar form. Polar form is just another coordinate plane you can graph on, but all you really need to know is how to convert them back into rectangular form, so into an imaginary number. De Moivre's theorem is the pattern that helps us do that. And then it states that if I have a coordinate point that is equal to r times cosine theta plus I sine theta, that I can turn it into a complex number using this formula, which is r to the n power or times cosine n theta plus I sine n theta. So this is being raised to the sixth power. So this is going to be my n. My radius, or the r value, is the number out front, so the 2. And then theta is the angle measure, so this is still 20. Okay, so then I just want to go ahead and plug into this formula that I highlighted. So I'm going to have 2 to the 6th power times cosine of n, which was 6, times my angle, which was 20, plus I sine times 6 times 20. So I want to figure out what 2 to the 6th power is. This is 64. And then I'm going to multiply 6 by 20 to get 120. Then I want to evaluate both cosine and, actually no, first I want to distribute the 64 to both cosine and sine. So it's going to be 64 cosine 120 and then 64I sine 120. Okay, now I want to evaluate these two trig functions at 120 degrees. Remember, 120 is right here. So I have a reference angle of, this is the 120. So if I subtracted from 180, my reference angle is 60. In the second quadrant, only sine is positive. So when I figure out the value of, really I'm going to do cosine of 60 here. Cosine of 60 is 1/2, and since it's in the second quadrant, it's going to be negative. Then for this one, I have 64I. Sine of 60 degrees, this one's going to be positive because sine is positive in the second quadrant. But at 60 degrees, it is the square root of 3 over 2. then I just want to go ahead and simplify my expression. So I have 64 times -1/2. This is going to get me -32. And then I have 64i times square root of 3/2. So I can take the 64 and divide by the 2 to get 32. I still have that I, and I still have that square root of 3. So this is my final answer. Questions here? So then when I'm given complex numbers in polar form, so the real part and the imaginary part, I can write them in rectangular form, which is the form we would graph it in. This formula, I'm going to write it in as r cosine theta plus I sine theta. And I want to use my radius formula is the square root of a squared plus b squared. And then I'm also going to use tangent of theta is a over b to find my angle. So on number 2, it wants me to continue using this theorem and to write my answer in rectangular form. So first I want to figure out my radius, but in order to do that, I need to know my a and b. This is coming from the complex number form. My a is 1, and my b is also 1 in this one because of the number in front of the I. So when I go to find my r, it's going to be the square root of 1 squared plus 1 squared. 1 squared is 1, so really I have 1 plus 1 under that radical, which is the same thing as the square root of 2. So that is my radius that I'm going to use for this formula. Then the next thing I want to find is the angle to plug in. I do this by taking tangent of theta equals my a value divided by my b value. So a was 1, b is also 1. So really I have tangent theta equals 1. Then I want to look back at the chart from chapter 1 to see where tangent equals 1, what angle degree it is. So when you know what angle this is, just message it in the chat. So this is going to give us 45 degrees for our angle here. So now that I have R and my angle, I can go ahead and plug back into the formula at the top of the page. I have my radius, which is the square root of 2 to the 8th power times cosine 8 times 45 plus I sine 8 times 45. So then I want to figure out what the square root of 2 to the 8th power is, which if I take this on my calculator will get me 16. Then I have cosine 8 times 45 which is 360 plus I sine 360
I got a question.
Mm-hmm.
So it says right there, the cosine and then slash to the 8, and then slash 45 and slash slash. Where'd you get that 8 from?
8 was from the exponent.
All right, so that you're putting the exponent in front of both of them, cosine and sine.
Yep.
Because in the formula in the top it doesn't have
This
Oh,
one?
all right, yeah. All right, I was looking at the bottom one. All right, yeah, all right. I see it now. All right, thank you.
Yeah. Mm-hmm. Okay. So then I just need to evaluate at 360 degrees. So cosine at 360 is 1. And then sine at 360 is 0. So anything times 0 is just 0. It's really inside the parentheses, I have 1 plus 0, which is just 1. 16 times 1 is 16. Questions here? Okay, so before I put you guys into the breakout rooms, I just wanted to remind you guys to do the course evaluation survey. I think most people in this class have done it. It's the problem I'm seeing is just that you're not submitting proof of it if you want the extra credit. I think I still have about 4 or 5 people who haven't submitted it because it's anonymous. I don't know who has completed it. So if you would like to get that extra credit, make sure you submit the proof to me. Additionally, there is going to be a test on Wednesday. Going over these two sections, there is a review and video posted to Canvas already. And then next, yes, the extra credit that's been turned in has already been graded. Then next Wednesday is when we're going to take the final. It is scheduled from 7:40 to 9:30 p.m. So keep that in mind for next week. But this week you have a test, and after the test, I will post the review and video for that as well. So questions on any of that?
If we already did the
No class.
personal evaluation, how do we get it back to show that we did it?
You get an email confirming it, and then I think if you also, I think you can access it from Canvas, and then it'll also show you it there too, that you've already completed.
All right, thank you.
You're welcome. No class on Monday. Any other questions before I put you guys into breakout rooms?